Hello everyone, and welcome to another math tutorial. In this video we begin a new chapter, a new playlist on quadratic functions. The videos in this playlist will range from graphing quadratic functions, where we'll begin, to solving quadratic equations. We'll even touch on complex numbers and nonlinear systems. But this video and the next one are going to begin this playlist with graphing quadratic functions. As our initial investigation into the quadratic function, let's look at what we call the parent function, which is just simply the most basic quadratic function we can have. It's just simply x squared. There's nothing else added or multiplied or anything like that to the x squared. It's just x squared itself. And we're going to look at this numerically by creating a table of values. And a pretty standard table of values would be one where we start at 3 and go to -3. Okay, so we're going to take these x values and we're going to substitute them into the x here. And we're going to work out the y value. So we're going to do 3 to the second power. So that's 3 times 3, we get 9. We're going to do 2 to the second power, and 2 times 2, 2 squared is 4. And 1 squared is 1. 0 squared is 0. -1 squared, so recall that when we square, we're taking it times itself. So this is -1 times -1, which is +1. -2 squared, likewise, is +4. And -3 squared is +9. So there's our table of values. Now let's plot those as coordinate points on the graph. So starting with the 3, 9. Got 2, 4. 1, 1, 0, 0, -1, 1, -2, 4, and -3, 9. If we connect these points, we get a graph that looks like this. The graph of a quadratic function we call a parabola. Now, some features of this graph, or maybe just some vocabulary, some things that we would like to know. The point here at the bottom is called the vertex. And then in this particular graph, the y-axis we call the line of symmetry. Okay, if you could imagine kind of like a imaginary line here that cuts the graph in half. We call that our line, or sometimes you see the word axis of symmetry. So that's all we're going to hit on right now as far as properties of this graph. We're going to talk a little bit more in the next video, some other features of the graph, but for today in this video we're just going to talk about vertex, line of symmetry, and then how to graph this. There are a couple different forms that you're going to see very commonly for quadratic functions. The one that we're going to go over in this video is called vertex form, and vertex form draws a lot from our transformations that we're familiar with. Let's explain that with the vertex here. So we've got this function. It is an x squared function, so it is a quadratic function. We just see that we've got this these extra numbers added and subtracted. We've got this number we're multiplying by. So we've got some constants there that are going to enact some change on the quadratic function. The first being the vertex, where we're going to start. So the vertex for this quadratic function is at the point HK. We just simply take this number is our x, this one is the y. But really what's happening is that's our transformations, right? We talked about transformations on the inside of the function, so this minus h is on the inside, And we know that if we are adding or subtracting inside, it's left or right movement, and we go opposite of the sign. So minus h actually goes in the positive h direction. We know that numbers added or subtracted outside are up and down, and you do what the sign says. So plus k is a positive k here. So these two numbers are just transformationally moving the vertex off the origin to this coordinate point. Now, because we have also a line of symmetry we talked about, let's go ahead and write that. Now, the line of symmetry simply goes through the middle of the parabola. It goes through the vertex. So whatever the x-coordinate of the vertex is, that's where the line of symmetry is. So this h here is the same number right there. Last number to talk about is this value that's out in front of the x squared, and that's the a. And this number is your stretch or shrink factor. And if that number is negative, we're also going to reflect the graph over the x-axis. We're going to flip it upside down. So let's go ahead and jump into just some example problems. We should be very familiar with the transformational effects of all these constants, and we're getting familiar in this video with the point pattern for the quadratic function. And the idea is we're just going to kind of put those things together to be able to graph quadratic functions in this vertex form. First example problem, we're asked to graph the function f of x equals quantity x minus 4 squared minus 6. I'm going to show you two ways to do it, and then you can decide which way you like better. I am more a fan of the second way that I'm going to show you. So after this first example slide, I am going to predominantly just show you this technique for the rest of the examples in this video, but I want to offer both so that you can choose kind of which you prefer to do. So the first thing that we can do is we can take every point of the parent function and we can move it according to these transformation rules that we have here. So let me go ahead and just copy down or replot the parent function on this graph here. Okay, there's our basic parent function for y equals x squared, our quadratic function. Now we want to move it, and according to these transformations rules up here, the minus 4 is going to move the graph to the right 4, and then the minus 6 is going to move the graph down 6. So if we just do what we have practiced in the past, we simply need to take every point and move them right 4 and down 6. So this point, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I'm going to do that to all the points. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And there we have it. Now, I think the process of moving every single point right 4 and down 6 can be somewhat tedious, and it's why I prefer this other technique instead. So let me talk you through this other technique, and then you can make the determination of kind of which you prefer to do. Now, I am going to move a point, but I'm only going to move the vertex according to the rule. Okay? So my vertex, which is originally at the point 0, 0 at the origin, I'm going to move that point right 4 and down 6. So from 0, 0, I'm counting 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I've got that point. It's in the same place as it is over here on this graph. Now from there, all I need to know is my pattern for x squared. So my table of values, I just need to know that whether I have positive or negative 1, it squares to 1. And positive or negative 2 squares to 4. And plus or minus 3 squares to 9. And so what I'm going to do is from that vertex point, which I have moved according to my transformation rules, I'm now going to plot this pattern. So I'm going to go from the vertex, positive 1, and it goes up 1. If I go back to the vertex, -1 goes up 1. I go back to the vertex, now I'm going to do the middle one here. I'm going to do +2, I'm going to go up 4, and then go back to the vertex, and now I'll do the -2. And go -2, up 4, and then finally I'm going to get these points down here. So go back to the vertex, I'm going to go 1, 2, 3, and I'm going to count up 9. I can do the same thing on the other side, go over 3, up 9, and you can see that the points land in exactly the same place as on the other graph with the other technique. So there you have a couple different ways to get that graph moved to the correct location. And again, I leave it up to you to decide which way you think is easier, which way you like best. I'm going to continue to practice this side over here for the rest of the problems that we're going to do together. All right, we are graphing on this slide f of x equals quantity x plus 3 squared plus 4. First thing I'm going to do is move the vertex off the origin. And I went ahead and set up a spot here. Let's just go ahead and write that out. So this +3 is going to move left 3. This +4 is going to move up 4. So my vertex is going to go to the point -3, 4. My line of symmetry is going to go through the graph at its vertex. It's going to be the equation x equals -3. So now on my graph, here we go. I'm moving the vertex from the origin, left 3, up 4. So right here. And now from that point, I just need to know my table of values. And I'm not going to write this every time. I'm just doing this for the purposes of instruction here. But it's pretty easy to memorize those points. I could even do this one, but that one's going to land off the graph on this particular one. So really, I'm just going to get these couple of points. 5 points is going to be enough, as we'll see. So starting at the vertex, I'm going to go 1 to 1, get it both directions, and then go 2 to 4. 1, 2, up 4, and 2 up 4. And as you can see, 3 up 9, I can't go 9 and land on the graph, so I'm going to stop right there. And that's the graph of this parabola. Next example, f of x equals 2 times quantity x minus 4 squared. First, let's talk about the vertex. This -4 is going to move the graph to the right 4. And then there's nothing else added out here, right? There's no plus number or minus number, so my vertex is just going to be 4, 0, 0, because there's nothing else out here that's adding or subtracting that's going to move this graph in the vertical direction. My line of symmetry is the equation x equals 4. So let's go ahead and plot my first point. My origin point 0, 0 traditionally is now being moved to the coordinate point 4, 0. Right here. Now, my table of values, which is my pattern, this is my fallback and how I'm graphing these. 1 squares to 1, 2 squares to 4. I'm going to stop there. Let's go ahead and write the next one anyway. You'll see why I'm stopping, but here we go. Now, the 2 in front has the effect of stretching the graph times 2. Okay, so it's going to stretch times 2. So what I need to do down here in my table is I need to take all these y values and I'm just going to take them all times 2. So this is going to become 2, this is going to become 8, this is going to become 18. So now when I go from my vertex, when I go 1, I'm not going to go up 1 because I'm multiplying it by 2. I'm going to go up 2. So 1, 2. And then I go to the negative direction 1, also up 2. When I go 2, normally I go 2 up 4, but we're not going to go up 4 this time because we've scaled it times 2. We're going to go 2 up 8. So I'm going to go 1, 2, and then count up 8. And then over 2 to the left, up 8. And you can see then why I'm skipping this number, because I can't go up 18. It's going to land off my graph. Had my vertex been way down here and I could fit that count, then I would do it, but can't, so I'm just going to go with these 5 points, and that's enough to go ahead and draw the parabola. And that's it. There's our graph. Next problem, we have f of x equals negative quantity x plus 3 squared plus 2. This plus 3 is moving the graph left 3. This plus 2 is moving everything up 2. So my vertex point is going to go to negative 3, 2. My line of symmetry is going to be x equals negative 3. So let's go ahead and take our vertex off 0, 0. Let's take it to negative 3, 2, left 3, up 2. So we're going to start right there. Now our table of values again. And you can, of course, stop writing this down if you've got it memorized. And all the quadratic functions are going to have this table, so it's pretty easy to memorize. Now this graph has a negative in front. The negative is going to take all these points, is going to multiply them times negative 1. In essence, what happens is it just makes them all negative. What happens is that negative flips the graph upside down, okay? It's not taking this point and moving it to the other side of the x-axis though, because I've applied these kind of out of turn. I didn't follow order of operations. So all it does in effect is it just flips it upside down where it is at, okay? So I'm going to do my 1, 1, but I'm going to go 1 and down 1 to make it go down. Instead of 2, 4, we're going to go 2, negative 4. And 3, negative 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to there. I haven't really said it yet, but I have been using symmetry to graph these really fast. I know that right here is my symmetry line, so this point here, it's just going to be a mirror image over to this side. So you can certainly be doing that to plot points really quick. And then we're going to connect them with our parabola. That's it. All right, our next problem says half x squared minus 5. Notice that this problem doesn't have any numbers added or subtracted inside the power. So when I write my vertex, there's no left or right movement here. So the vertex is going to stay on 0. That minus 5, however, is going to move the graph down 5. So 0, negative 5 is our vertex. Our line of symmetry is going to be the equation x equals 0. So we're going to start this here 1, 2, 3, 4, 5 down to that point. Now our table of values. So plus or minus 1 gives 1, etc. The same table we've been using, like so. Now the half in front, this is going to shrink all these values, but we're just going to multiply everything by half. So what's half of 1? It's half. What's half of 4? We get 2. Half of 9, we get 9 halves, which is 4.5. Let's go ahead and do another value, because I don't really like graphing the points on the halves sometimes. Let's just go ahead and look at 4. We haven't looked at 4 yet, but we certainly can. 4 squared is 16. And the reason I chose 4 is because I can take half of 16 really easily. So that's another point that I could use on this graph if I want to. So let's just go ahead and I'm going to graph this one right here. I'm going to graph this one. I think that'll give me 5 points. That'll give me enough. And then I'll avoid graphing the halves. So it's a choice I'm making to just, choosing to graph the points that I think are easier to graph. So let's see, 2 is going to be 2, and negative 2, negative 2. 4 is going to be 8. So from the vertex, 1, 2, 3, 4, and then count your way up 8, and then negative 4, up 8. One more up to there. If you want to do more points, you can do more points. You know, if I want to do 1/1/2, I can go 1/1/2. I can put that there, put that there. So that's up to you, but you get 5 points, that's probably enough. Okay, there's our graph. All right, if you think you've gotten the hang of this, you can certainly end the video now. But I do have a couple more examples that I'm going to go through. But I did put here that this is an example for you to try if you would like. This one and the next one. So if you're feeling up to the challenge, go ahead and hit pause on the video. Try and graph this one on your own. And then when you think you've got it, hit play and do a quick check of your work. I'm going to go ahead and continue, assuming that you are going to do that. So my vertex here, this is going to move the graph left 3 and down 6 to that point. My line of symmetry is going to be x equals -3. I'm going to start -3, -6. My table of values, my pattern, 1 and 2 give 1 and 4. I think that's probably going to be good because I'm going to take these numbers and I'm going to make them times 3. So 1 times 3 is 3, 4 times 3 is 12. I think anything more than that's going to take me off the top of the graph. So from the vertex, 1 goes up 3 and -1 goes up 3. And then 2 goes up 12. So 1, 2, up 12. And then left 2, up 12. A little harder to graph these by hand, I think, when points get so stretched out because it gets kind of so narrow, so skinny. But let's see how we can do here connecting these. All right, there we go. It's all right. It's not perfect. It's not beautiful, but you can get the idea. We've connected the points. I think with all these, you're going to need 5 points to plot. So usually just a couple values into the table will get you those 5 points coupled with the vertex. All right, let's do the last one. Okay, again, go ahead and hit pause. Try this problem on your own, and when you've completed it, hit play, and let's see what you got. Now, our vertex -4 is going to go to the right, +9 is going to go up, so our vertex is going to be at the point 4, 9, with an axis or line of symmetry of x equals 4. So let's begin by plotting that vertex point at 4, 9. Now our table of values. Again, I'm just going to do the first couple of spots here, first couple rows. 1 gives 1, 2 squared gives 4. I'm going to multiply by -2. The y values times -2 is how I'm going to scale them. 2 is going to stretch them, and the negative is going to flip it upside down. So +1 times -2 is -2. +4 times -2 is -8. If you want to do one more, you can certainly do 3, 9, and 9 times -2 is -18. I think by the location of that vertex, that's going to fit, so you can certainly do it. So here we go. 1 gives down 2, both directions. 2 gives down 8, both directions. And 3 goes down 18, so there's 3. 18 would be 9 to there and 9 more to right there. So it just fits. We've got the same point on this side, and then we go ahead and try and connect these points. Okay, that concludes this video on graphing quadratic functions in Vertex Form. If you have any comments or questions, please feel free to drop them in the comments section below. If you found the video helpful, please support the channel by giving it a thumbs up. Be sure to click that bell for any posted notifications for the channel. And as always, I thank you for watching all the way to the end, and I'll see you in the next video.